In this session, let us discuss about space to time. Okay. In previous session, if we supply time displaced currents, in space MMF is going to rotate, so that is time to space. Now we are entering into space to time. Okay. Space to time in the sense input should be space, output should be time. This is stator. Now let me have rotor, pole. This is N pole, this is S pole. Okay. Now if I have one conductor here, okay, called as A, written conductor here called as A dash, means that my conductor is going to start from here to here A, back to back connection A dash. Okay. So this is going to be the coil A, back to back connection A dash. Okay, that way. Now for example, if I rotate this in this direction, as of now, how much will be the induced voltage here? Flux is here. Okay, pole is here, so flux is coming out of the pole. Okay, so as of now, flux density is maximum here, flux density is 0 here, flux density is negative maximum here, flux density is 0 here, if I consider north pole as positive. Okay, now if it is rotating in this direction, as of now the position of the pole is here, means that induced voltage here will be 0. Now if I rotate 90 degrees in space, space is the input. Okay, so if I rotate this 90 degrees in space, induced voltage will be maximum. Okay, so if I rotate this, as of now induced voltage is 0, if I rotate this by 90 degrees, induced voltage is going to be maximum. For example, let me draw induced voltage here, induced voltage in conductor A. Okay, I am assuming ideal case, in the sense flux density distribution of the pole, I am considering it as sinusoid. As of now induced voltage is 0, after 90 degrees induced voltage is going to maximum, so sinusoidal induced voltage will be like this. Okay, so as of now induced voltage, what is this x-axis? Time, omega t. Okay, so as of now induced voltage here is 0 when pole is here. When pole is rotated by 90 degrees in space, induced voltage here will be moved by 90 degrees in time, because sin 90 is maximum. Okay, so this is space to time. For example, if I have B here, B dash here. Okay, now as of now means like how to find polarity of induced voltage here, direction of induced voltage means direction of induced voltage, right hand. Okay, in right hand flux is in this direction, N pole, you have to sit in the air gap. Okay, and pole is moving in this direction, means that with respect to field, conductor is rotating in this direction, thumb. Okay, then dot, so this is going to be dot. Now this is going to be cross. As of now induced voltage is going to be maximum or not? Yes. As of now induced voltage is going to be 0 or not? Yes. After 90 degrees rotation, induced voltage here is going to be maximum, induced voltage here is going to be 0. Okay, so as of now induced voltage is going to be maximum here. After 90 degrees it will be 0, after 90 degrees it is going to be negative maximum, after 90 degrees it will be 0. So my induced voltage in B like this. Okay, so what it means what is the space displacement angle between A dash and B dash, B dash, A dash. So in space my windings are displaced by 90 degrees in space. Because of that, induced voltage in AB are time displaced by 90 degrees. Okay, let me repeat again. For example, consider only A. As of now it is here, poles are placed here. Now if I rotate this, think of A only, time displaced. Let us sit here and pass the time. As of now induced voltage in A is 0, positive maximum 0, negative maximum 0. So if I rotate this by one revolution in space, here induced voltage will be one cycle in time. Okay, now coming to the other point, as A dash and B dash are space displaced by 90 degrees, my induced voltage here are time displaced by 90 degrees. For example, if I have one more conductor, maybe here this is x, here x dash. Okay, so these b dash and x dash are space displaced by, for example, some theta. Okay, so b dash and x dash are space displaced because b dash and x dash. So b dash to x dash, MMF axes are displaced in space or not? Yes. So those are nothing but space displaced winding. So between b dash and x dash, my windings are space displaced by theta. So induced voltages between b dash and x dash is going to be time displaced by theta. Okay, so what is conclusion here? Very simple. In space, if I rotate by one revolution, in time it will be displaced as one cycle. So space to time is synchronized or not? Yes. Previously we synchronized time to space. Now we synchronize space to time. Space to time. For example, means most of the guys feel synchronous speed ns equal to 120 f by p, or okay, let me repeat ns, remove, or f equal to pn by 120. Okay, means actually we can derive this, it will take a bit much time. We will keep this for the detailed machines analysis detailed. Okay, now we are machines simplified. In future machines detailed analysis will come, there I will discuss in detail, but anyway what are the concepts required to crack GATE 2020 is our target. Okay, now are these two equations same? Are these two equations same? Mathematically f equal to pn by 120, so same equations? No. Okay, from analysis point of view both are different. In the sense, frequency, if it is the input, frequency is the input, means that time. Okay, in space speed will be there, space. Okay, so if time is the input, space will be the output. Okay, now here in this section, in space, if you give, in time this will come. Okay, for example, if I rotate this by one revolution, one cycle of induced voltage will come or not? So input is going to be space, I have to rotate, output is going to be time. Now let us think of whatever the previous discussion, that is time to space. A dash, B dash, C dash. Okay, in our previous session we considered a T1 IA maximum at T1, okay, and at T2 it became IB maximum. Now IA maximum to IB maximum, what is the angle in time? 120 degrees. So in space my MMF is rotated by 120 degrees or not? Yes. Okay, so T1 to T2 120 degrees in time is giving 120 degrees in space, resultant MMF is being rotated. Okay, for example, in time, if I give one cycle in time, okay, if I give one cycle in time, in the sense one cycle of currents in time, if I give the input, output, my MMF, resultant MMF is going to be revolved by one revolution. Okay, so coming back to here, if frequency is the time currents input, so in space it will rotate with this speed, and if you rotate this rotor in space, okay, in time induced voltage will be there. If I rotate this by 50 revolutions per second, okay, if I rotate this one revolution, one cycle of induced voltage will come here. If I rotate this 50 revolutions per second, 50 cycles per second will come. Okay, 50 revolutions per second into 60 is going to be 3000. Now if I rotate this with 3000 rpm, my frequency of output is going to be 50 Hz or 50 cycles per second. Okay, so in this way, in the upcoming video we are going to discuss about time to space to time, and next space to time to space, then our basics will be over. We can very soon start our synchronous.